Hi, in this video, we are going to be looking at sections 4.5 and 4.6, which deal with combinations. So these are slightly different than permutations. With permutations, the order that things were selected was important. With combinations, the order does not matter. So therefore, it's a slightly different calculation to get amount of combinations versus amount of permutations. So combinations is a grouping of objects where order does not matter. So for example, a company is hiring 4 employees. They have 20 people apply. It doesn't matter which order they hire those 4 employees. They are just hiring 4 employees. Doesn't matter if one's first, second, or third, and fourth. So our notation for this is NCR, or we can write it in brackets of N over R. You'll notice we do not have a line between the N and R. And N is our total amount of objects, and R is the number of objects chosen. So NCR is equal to N factorial over R factorial times N minus R factorial. So for example, with Lotto Max lottery system, 7 numbers are selected from a group of 50. How many combinations are possible? So 7 numbers are selected. The order that those numbers are pulled out doesn't matter because they're then reordered into ascending order. And we just want to know how many combinations are possible. So our 50 is going to be our N. We're selecting 7 numbers, so that's our R. So we know our equation takes the form of N, or our notation is NCR, so that would be 50 C of 7. We can go into our calculators and solve this. If we have a Texas Instrument, it is going under math, going over to the menu for PRB, and then scrolling down to third one, NCR. So we'd have 50, we'd go into there, select the NCR, and then put the 7 in, and hit enter, and that should give us 99,884,400. So that's essentially how many unique tickets can be made. Now, for example, local arena has 10 applicants for jobs. How many ways can 4 applicants be chosen, and how many ways can 6 applicants be chosen? So we could use VAP on our calculators for this. However, I want to do this one by writing out our formulas because we're going to notice a pattern between these 2 answers. So this is going to be our N, and for the first one, this is our R. For the second one, this is our R. So if we have NCR for this one, that's going to be, for A, that's going to be 10 C of 4, which gives us 10 factorial over 4 factorial times 10 minus 4 factorial. So that gives us 10 factorial over 4 factorial times 6 factorial, which if we calculate gives us 210. For part B, we'll do the same thing. So NCR is equal to, in this case, we've got 10C of 6. So that's going to give us 10 factorial over 6 factorial times 10 minus 6 factorial. So that gives us 10 factorial over 6 factorial times 4 factorial, which also gives us 210. So you'll notice we got the same answers. So essentially, if we take our n and subtract our r, the value we get there, if we substitute into another equation as our r value, will give us exact same answer. And the reason for that is how many ways can 4 applicants be chosen would be the same as how many ways can you choose 6 that are not going to get the job. So therefore, we get the same value.